Hi friends, welcome to chemistry class. In this case, I'll be talking about empirical and also molecular formula. But actually, I need to divine. I need to tell you guys the meaning of empirical formula and also the molecular formula. So in this case, we are talking about empirical formula. Empirical formula is just a type or a kind of formula that indicates the simplest ratio of a particular compound. Okay, it indicates the simplest ratio of a particular compound, while the molecular formula tell, tells us the actual number of atom present in the compound. So empirical formula is saying that it indicates the simplest ratio of number, and molecular formula tells us the actual number present in a particular compound. So now let's take a look at the series of questions I'm having here. I think I'm having up to of 3 questions here. So in this case, let's just solve this, right? So now the question is calculate the empirical formula of a component containing what 43.4% of sodium, 11.3% of carbon, and 45.3% of oxygen. Now in this case, what you can just outline all the elements that we're having here. The first element that we are having here is what? That's sodium, and sodium is what? Is Na, right? And we are having sodium, we are having and also what? Carbon here. So in this case now, the total number of sodium and also carbon here is 11.3 plus what? Plus 45.3, right? So 11.3 plus 45.3 is what? 11.3 plus 45.3. This is actually what? 56.6. So it is not up to what? Up to 100%. So it shows that what? There is another compound here. There is another element here. Okay, and the element, okay, we are giving the element is actually oxygen. So this is it. We have what? Oxygen, which is 45.3, right? So I think everything is all balanced now. So at first, these what atoms that we are having here, the elements given what that are contained what inside the compound, because we have to calculate the empirical formula now. But we need to write that percentage by mass out. So writing that out, we have what our sodium is actually that's 43.4%, and our carbon is what 11.3%, and while oxygen is what is 45.3%. So after that, then we need to write their mass, the mass of what of elements out of each element. The mass of sodium is given by what is given as 23.0, right? And the mass of carbon is actually 12. The mass of oxygen is what is 16. So in this case, the next thing you can do is just to divide. You find the ratio between the percentage by mass and also the mass of the elements. Since empirical formula tells us the simplest ratio of a particular element present in a compound. So now let's go and let's just divide everything. Let's find the ratio. In this case, I'm having 43.4 divided by 23, and 11.3 divided by 12, and 45.3 divided by 16. Then let's look at the answer. Let's see what's this one. 43.4 divided by 23. That's what? That's 1.886. Okay. Then 11.3 divided by 12. That's what? 0.942. Then okay, the last one, 45.3 divided by 16. Give us what? That's 2.831. So now the next thing is just to divide by the smallest, since we are after the simplest ratio. Then let's divide by the smallest value. The smallest value here is what actually was 0.942. So you have 1.886 divided by 0.942. Then this 0.942 by by itself. Then 2.831 divided by that's 0.942. So in this case, I'll be having this divided by this. We actually give us this 0.9. That's this one should give us 2. This one is 1. That's 2 ratio 1. Then let's check for this. That's 2.831 divided by 0.942. So we have we have 3. So you have ratio what? Ratio 3. So in this case, 2 multiplied by n2 Na, that's what? Na2. This is the simplest ratio of what? Of simplest ratio of sodium that is here. Carbon multiplied by 1 will give us 1 carbon, and also what? O3. So this is actually what? Sodium carbonate. So in this case, this is the what? Empirical formula of what? Of this compound. It shows what? The smallest ratio, 2 ratio 1 ratio what? Ratio 3 of each element present in what? In sodium carbonate. Then let's move to the next question. Find the empirical formula of an oxide of iron. We are asked to calculate for the oxide for the empirical formula of an oxide of iron in this case, but we know that iron is Fe, right? We are having Fe, and it contains 70% of iron. If iron contains 70%, we are asked to find the oxide. That means iron might have been combusted or react with oxygen to form an oxide. So the oxide is actually what is called iron oxide. So in this case, we are given a percentage of what? Of the iron that reacts with what? With oxygen. Then we are not given any percent of what? Of oxygen. That means we need to find the percentage of what? Of oxygen in this case. So in this case, we are having what? We are having 70.0% minus what? 100%. That's actually 100% minus 70.0%, which is actually what? 30 what? Percent, right? So out of 100%, it shows that what? 70% of iron reacts with 30% of what? Of oxygen to form what? Iron oxide. So in this case now, we're having Fe and also what? Oxygen here, right? So in this case, you can say maybe it is atomic oxygen or molecular oxygen or atomic oxygen. We can't say either between the three. Maybe it is monoatomic oxygen, diatomic, or what? Or molecular oxygen, which is known as what? Molecular oxygen is actually O2. Why ozone? We don't know. Maybe it is what? Ozone. So let's just leave it like this and solve it directly. So in this case, you're having 70% of iron, 70%, right? 7.0, and also having what? 30% of what? Of oxygen. Then we know that the mass of what? Of this is the percentage by mass, and also we have the mass of what? Of elements. The mass of element of what? Of iron is actually what? 56, while the mass of oxygen is what? Is 16, right? So now let's find the ratio. 70.0 divided by what? 56, and also what? 30.0 by what? By 16. Then what's the answer here? That's 70.0 divided by what? 56 is actually giving what? That's 1.25, and also what? 30 divided by 16 will give me what? That's actually 1.875. So next thing is to what? To divide by what? By the smallest value, right? So the smallest value here is actually 1.25. So 1.25 by what? 1.25, and also what? 1.875 by what? 1.25. So this by this gives us 1 ratio. So divided by 1.25, you have what? That's 1.5. 1.5 in this case, we can actually approximate it to what? To 2. So in this case, we have what? We are having 2. So this is actually the empirical formula of what? Of iron oxide, Fe2. Okay. So in this case, we have what? 1 ratio 2. Therefore, this is taken to be what? The smallest ratio. And empirical formula tells us the what? The smallest ratio of what? Of each element present in a particular compound. Then let's go for the last question here. The last question I'm having here is what is the empirical formula of an organic compound? This one is organic compound, not inorganic compound, containing 40% of carbon and 66.67% of hydrogen by mass. If you are talking about organic compound, if it is an non-organic compound, we know that there are some elements that react together to form the particular compound. But in this case, organic compound containing 40% of what? Of carbon, we need to verify if the total percentage is up to 100%. In this case, we are having what? 40% of what? Of carbon, and also what? And also 6.67% of what? Of hydrogen. Let's verify. This is actually what? This is 46.7 in total. It is not up to 100. Then we know that organic compound contain what? Is the carbon of what? Of is the compound of carbon and also what? Hydrogen. And also let's include oxygen, because if a particular compound, if you boil a particular compound, it's going to give out water. The water given out, it shows that the presence of oxygen, or we know that the atmosphere also contain what? Oxygen, but oxygen can easily combust with what? With other organic compound. We know about that. For example, in the let's say we're having let's say, okay, let me use alkene, propene, something like that. Propene, let me use propene. Propene reacts with what? With oxygen. It's going to combust to form a what? To form another homologous what? Another family, actually, to form another group of what? Of organic compound. So in this case, you can actually say that oxygen is what? Is present. Yeah, it's present, because if you have a particular unknown organic compound, and then the percentage is what? Is not up to 100%, that means the next element that we should assume is what is, it is oxygen, because oxygen also what take part in what? In organic reaction. So in this case, what is the empirical formula of an organic compound containing 40% of carbon and also 6.67% of what? Of hydrogen. So in total, everything here is just 46.67. Then let's just subtract 100% by what? By 46.67. Let's say the answer, that's 100 minus 46.67. So what's the answer? This is actually what? 53.33. This is 53.33, right? So in this case, it shows that oxygen has what? The total percent of what? Of 53.33. Now let's go ahead. The first element is carbon, the second is hydrogen, the third is what? Oxygen. Now then the percentage by mass of what? Of carbon is 40, while that of hydrogen is what? 6.67, while that of oxygen is actually what? 53.33. That's the percentage by what? By mass. Then let's go to the mass. The mass of carbon is taken to what? To 12. The mass of hydrogen is 1. The mass of oxygen is actually what? 16. Then let's find the ratio directly. That's what? 40 by what? By 12. 6.67 by what? By 1. Then 53.33 divided what? By 16. Then let's check the answer. We're having 40 divided by 12. Then what's the answer here? That's 3.333. We're having 3.33. Then this one is actually 6.67, because we divide it as well. Then you have 53.33 by what? By 16. Let's see the answer. That's 3.33, right? So then what's the next thing? We need to divide by what? By the smallest. Divide by the smallest ratio, right? By the smallest value, actually. So you have what? 3.33 by what? By 3.33, because that's the smallest value you're having. 6.67 divided by what? 3.33. Then the last one, 3.333 by what? By 3.33. This goes in this. This goes in this. That's 1 ratio. This is actually 2 ratio. That's 1. Okay. So in this case now, the smallest ratio here is what? Is 1 ratio 2 ratio 1. So that you have what? You have C1, H2, and also what? O1.